Simple tip Sunday today with the Mastercraft. If you don't know how to use one of these, don't bother getting a Martinez square because it won't do you any better. So let's say you're doing a 6/12 pitch. You can get our plumb cut just by turning out to the 6 right there. If you want to get your reverse or your seat cut, you can flip your square in that direction, mark it there. You can also get that seat cut or reverse cut by marking your 6/12 there, pivoting out this way. There it is again. Or you can also do it this way. Turn out to your 6/12, mark it, and then turn it to this line that's on the square. And there's your bird's mouth. Boom. Simple tip Sunday, straightening walls using the 3-block method. We put a block on our level corner here and a block on our level corner at the opposite end. Then we take a gauge block of the same size and check along the distance of the wall, see where it needs to move. Like here it's contacting the string, so we brace it there, push it out, and make sure we're parallel with that string along the entire distance of the wall. Simple tip Sunday. How many times has this happened to you? You're removing some screws. The first one comes out just fine, but the second one stays stuck in the material that it's coming through. Instead of taking the first one out the entire way, leave it halfway. That way it'll hold your material down and allow the thread of your second screw to engage in the material, then both can be removed properly. Simple but effective. Simple tip Sunday. We all work alone and sometimes need that third hand to hold something up for us. It's always in your pouch. Grab a hand spike and your hammer. Sink it right near the end. Bend it over, and you can hang a joist on the other side, or if you turn that sideways, you can hang your fascia, nail one end, and then move down. You've got that hanging point. Use this trick thousands of times. Simple tip Sunday, the speed square. What's this line for? This cheap Mastercraft has it, the next model up has it, this 12-inch Craftsman has it in 2 spots. Martinez has it. So what that's for is when you're doing your rafter layout and you need a seat cut. Let's say we're on an 8/12 pitch. We take the 45 on our protractor edge, our plumb line, and that mark on the square. Line all 3 of those up, and that gives you your seat cut. So depending on where this line is on the square will determine what the seat is. Being at 75 degrees there, that gives you a 3-inch seat. This one's on 80 like the Swanson, that gives you a 3.5-inch seat. This one's got a 5-inch and a 2.5-inch seat just because of the larger scale. And this one has a very strange 2 5/8. Simple tip Sunday, stair math basics, how to calculate the rise of your stairs. Let's say we've got a total rise of 35 1/4. How do we figure out what our even steps are going to be in that? What I do is I take what code is here, which max rise of 7 7/8, divide those two together, which gives me 4.48. It doesn't matter what that number is, always round it up. So we're going to say 5 steps. Then I take my 35 1/4, I divide it by my 5 rise that I'm able to do to keep me under max code. And that gives me 7 1/16 for each of my rise. Then when I cut my stringer, I'm going to remember to subtract the thickness of my riser and subtract the thickness of my tread when I cut my stringer, and those stairs will fit perfect every time. Okay, the simplest way I can explain this. Each of these is a 1/2-inch rise, 2.5 inches. You can see that right there. So, cut my stringer, 1/2-inch rise for each. What I need to do is account for my tread thickness because we don't have any of those yet. So we cut our tread thickness off the bottom here. That brings everything down here. Everything's level, tread thickness on each stair. Rise is perfect. Simple Tip Sunday stringer layout. We're using some imaginary numbers here. 7 7/16 rise, 10-inch run, 1-inch nosing, 11-inch tread length. And with that, we're going to pretend that we have a 5/8 riser board and a 1-inch tread board. So just get this marked out real quick. So there's our basic stringer. Now what we want to do is accommodate for our thicknesses of material. So at the bottom here, this is where our subfloor would be. We're going to subtract 1 inch off our rise there, like that. And at the top, we're going to subtract 5/8 for our riser board off our run right there. And what that does accommodates for the thicknesses of our material. So our riser board that we're going to use to hang our tread goes there, which will shorten this. But then this riser compensates for that, and we use a rise at the bottom that's 1 inch shorter than the rest. And then when our treads go on, we still have the same rise and run everywhere. Whereas if we don't compensate, then we are adding 1 inch to our rise there. And if we don't compensate for this one over here, then our nosing becomes one riser thickness short. Hope that all makes sense. If you have any questions, leave them in the DMs. Simple Tip Sunday, finding the rough opening for your stairs based on either your desired headroom or your required headroom. We're going to go with a required headroom of 6'8" for this example. You can see I have my other numbers here, including my floor thickness, which includes my 1/2 inch drywall, my 3/4 inch flooring, my 5/8 sheathing, and my joist depth. That's important because we're going to use ratio and proportion with our rise and run of our stair to the rise and run of our stair opening. These are similar triangles, this one here and the larger one, so we can just cross multiply to get it. We're trying to find a horizontal value of x, so we use our 9-inch run compared to our unknown, divided by our vertical rise of 7 7/16 over our headroom plus our floor thickness. So 6'8" plus 11 1/8 is 91 1/8. Cross multiply to simplify for x, that gives us 110 1/4. After that, you want to add 3 inches for your finishes on each side, and that'll ensure that you have a proper rough opening once all your finishes are applied. Simple Tip Sunday, sneaking up on your marks. So I always just eyeball down my blade to where my mark is. I don't have a zero clearance. And I'm just that little bit off. So I can actually use the blade to gauge how much material I'm going to take off, since the teeth are wider than the plate. So I just butt my piece into the plate, lift the saw, run it. And now I've snuck up on that mark. Needs just a hair more. We'll do it one more time. Gauge it on the plate. Run the saw. Right on the money. Simple Tip Sunday today. Your sheathing lines for cuts, don't bother pulling out your chalk line. Just pull your measurements, flip your tape upside down, get it on those marks. Ride one finger on one side of the blade, your pencil on the other. You've got a perfect guide to make your cut. Hope this helps. Simple Tip Sunday with the tape measure, something real easy today. We've all gone to scribe that line, dragging the finger across the sheet of plywood like that and gotten a huge sliver in there. Instead, just lock your tape on your measurement, slide that nice piece of metal right there across the edge, avoid all slivers. Perfect. Tiny Tip Tuesday. Say you're doing some layout, you make a mistake, rubber overmold on your tape measure acts as an eraser. The reason I know this is because Jake taught me that. His tape measure is basically yellow. Thanks, buddy. The right angled triangle is a carpenter's best friend. Whether it's the 3-4-5 for squaring something, or doing stair layout, roof layout, you need to know this math. A squared plus B squared equals C squared will get you lots of places, but it's not always understood. So if we have a side of 3 and a side of 4, using this theorem, that gives us a hypotenuse of 5. Why that works is if you have 3 squared, that's 9, 3 by 3. 4 squared, 4 by 4 is 16, which gives you 16 plus 9 is 25. And you can see the proof right there with these Matthew C blocks. It was actually my kids' homeschool math program that proved this theory right for me. I've got a post and beam going above to hold the roof for my deck, but how do I figure out my post height with the deck drop? What I'll do is I'll grab a level, put it on the door plate or the wall plate that's still inside the door there. I know my cripple height is 98, so I take my level, bring it up to level, measure the difference to where my post needs to sit, in this case 4 1/4 inches, add that to my 98-inch cripple height, there's my post. Sunday. Most carpenters' bags make it easy to grab a full-size pencil. But once you sharpen that down a few times, it can get lost in there, making it real difficult to get it out, doing a layout and such. There it is. What I find is when your air hose pops, grab a chunk off the end, and you can slide that over the end of your pencil, and you always have a nice size pencil to grab. The other option is you can put a piece of keel in the end, lumber crayon, and then you got a double marker. Another option is the big Pika. Shove that thing in your bag, you always got a full-size pencil. Simple Tip Sunday, calculating your rafter length in a few different ways. We've got a 6/12 pitch on a 16-foot span, which gives us an 8-foot total run. So we can do a full scale math out, which gives us a 96-inch total run. 96 divided by 12 is 8. 8 times 6 is 48. Total rise. Do Pythagoras, a squared, b squared, c squared gives us a 107.33 diagonal, which is then our theoretical rafter length. You can do this also by getting the run of the slope on your unit of run. So we a squared, b squared, c squared this to give us 13.42. That number is also available on your rafter square, so you don't need to math that one out. Then we take our total run, divide it by our unit of common run. In this case, that gives us 8 units of run. I can't spell. 8 units of run multiplied by the diagonal slope value gives us the 107.33 theoretical rafter length. The last way you can do this is to take your theoretical rafter length divided by your common run length. In this case, that is 1.1183. Multiply this number by your total run, and that will give you the same value. So there's 3 different ways to math out your rafters to get your theoretical rafter length. After that, shortenings and adjustments, and you are good to go. Questions? Leave them down below. Math Theory Monday. Let's visualize what we talked about on Simple Tip Sunday. So we have a run of 96 inches and a rise of 48 inches for our pitch triangle or slope triangle of a 6/12. So what that means is we take our 12-inch run and divide that into our total run, which gives us 8 pieces. So here we can fit 8 of our pitch triangles along the run of our roof section. So we want to calculate this length. So by using our diagonal measurement here based on our 12-inch run here, that gives us our 8 units of run to get the length up the slope. So back to this one, 12, 6, 13.32, 8 units of run in the 8 feet, times our 13.42, gives us 8 units of run on our diagonal. Hopefully a visual helps us understand the math a little bit. Maybe we'll do this more often. Simple Tip Sunday, rafter layout with no trigonometry. So we've got a 30-inch run over here and a 9-inch overhang on a 6/12 slope. So 30 divided by 12 is 2.5. So we're gonna lay out 2.5 runs. So there's our theoretical top. 1 run, 2 run, and for our half run, we mark that one, come back to half our run, which is 6. That's where our bird's mouth is going to be. And from there to our fascia line, we need 0.75, which is going to be 9 inches, so between 3 and 12. And there's our fascia line, shortening and adjustments, and you've got a rafter length. Simple Tip Sunday, calculating the magic number for an unequal pitch roof for sheathing. So we're gonna work on our major slope here, which is our 6/12. And this is a relationship between your theory length of your rafter and the common run of your minor. So theory length of your major rafter and the common run of your minor roof. If you're sheathing the minor side of the roof, it's gonna be the opposite. So what we need to find out is what our rise is at 48 inches up the slope of the common rafter. So we use our pitch triangle, our 6/12 and our 13.42 slope off our rafter square to calculate what this rise is. So a rise of 6 is equal to our unknown if it's divided by 13.42, which is our common rise, over our desired 48. Cross multiply by 48 to solve for x gives us 21.466. Now this magic number is going to be equal to the run at the same rise on our major common. So our major rise here of 21.466, our magic number is that run at the same rise on our minor roof. So now we are calculating x of run over 21.466 rise on our 10/12. So to do that, we take our rise of 10 is equal to 21.466, and our unknown is equal to 12. So then again, we cross multiply to solve for x. This is ratio and proportion, and that gives us 25.75. 25 3/4 is our magic number for sheathing the major side of this roof. Real confusing, not the simplest tip. I'll answer questions in the comments. Simple Tip Sunday, bending a framing member around a curve. So here we have a layout 90-degree corner with a 12-inch arc connecting them. To make that curve out of a 2x4, we measure out our radius, 12 inches, and we will scribe that through nearly all the way with our saw. Just like that. And with our radius cut, curved almost all the way through, we lift this end up to close the curve and measure the distance off the ground on this side. Works out to be 5/8. So that distance that this moves when the kerf is closed is the gap between each of our cuts. Now to get this curve arc length, we take the length of the arc and make a kerf every 5/8 for that arc length. In this case, a 12-inch radius for 90 degrees is going to be 18 3/4 plus. And so we measure out every 5/8 along there. Make the kerf. I'll speed this up for you. Now with all those curves done, should be able to get that to follow our radius just perfectly. There it is. Calculate out how to curve your wood. You can do it with dimensional lumber. It's a lot easier with like 3/4 plywood. Simple Tip Sunday, circle math. Laying out a radius curve is simple enough, but finding out what the length of that arc is, you can't do very well with the tape measure. So math it out. It's real easy. Every circle has 360 degrees around that circle. So we can determine the circumference by going 2 times pi times radius. So in this case, our radius is 12 inches. So our circumference is 75.36 inches. 2 times 3.14 times 12, 75.36. Then we take our total circumference and divide it by our known 360 degrees. I did this earlier, I can't do it in my head. That equals 0.21. So for every degree that we move, we're going to have 0.21 of an inch. Obviously, that's more than 1 degree. Then we take our total sweep, in this case, 90 degrees, and that gives us a total of 18.84, or 18 and 13/16. That's how you calculate the length on an arc. Simple Tip Sunday, figuring out the cut for a shed dormer dying into a sloped roof. So we got some rafter stock here, 312 going on to an 812. So we're gonna start by marking the level cut of our 312 as if it was dying onto a horizontal surface. I've just doubled it to 612 or 624 to give me a longer line to deal with. Now we mark off of that level cut of the 312 our 812 value. Mark that on the level cut as well. And this line here will be the cut to make for that to work out. Pull off this for your rafter length, and Bob's your uncle. Simple Tip Sunday, getting error-free even spacing. So I've got a board here. It measures 42 and 5/8. Now if this was, say, a handrail run that needed vertical balustrades, then we would need to go 4 inches as our maximum between those. So what we can do is use a swing stick. Grab something that's longer, and we're going to go with the spacing of 4 inches. And I'm going to offset it off the end of my board by 2 inches. So let's mark out every 4. Alright, now that we've got our max spacing set, what we can do to get an even spacing across our odd measurement is line up our first mark with the edge of the board. So if this was between newel posts, you would put this on the edge of the newel post, and then you swing this stick until the other side lines up with the other newel post. So just using my square to get this to line up straight there. There we go. Now we can just mark our sole plate or our plywood or whatever we need to mark with those 4-inch marks we made on the swing stick, and you will have an even measurement all the way down your piece, and that'll be less than what your max spacing was. We are roughly 3 3/4. Don't use a Sharpie for precision layout. Simple Tip Sunday, Tool Tip Edition. The blade on this track saw is a 20mm arbor. That's not the most common size and a little bit more expensive, but you can run a standard 5/8 arbor if you pull this washer off and flip it over the other way. The blade actually indexes on a shoulder on the one side here, and it's got a wider shoulder on the other side, and this arbor shaft is 5/8. So you pop this back on the opposite way it came installed. You can slide a 5/8 standard 6.5-inch blade in there and save some money on some blades. I'll run this one first. Brad, thanks for the tip. Sold me on this saw. Well, at least one reason it sold me on this saw. Simple Tip Sunday, determining the handedness or the swing of a door. So I've seen lots of videos where guys, stand with your back, the hinges are here, it's a left-hand door. That's not the correct method. There are 4 kinds of doors. There's a left hand, a right hand, a left reverse, and a right reverse. So this here is a left-handed exterior door. To determine it, you stand on the outside, so I'm in the garage going into the house, or I could do an interior door standing in the hallway going into the bedroom or into the bathroom. And when you look at the door, which way is your arm going to swing when you open it? So here I would swing the door this way, so it's a left-hand door. And this is an exterior door, so it has weather stripping. So if I grabbed it and I pulled it open and it swings to my left side as I walk through, it would be a left-hand reverse. And why that's important is the weather stripping will be in a different location if it's a left-hand or a left-hand reverse. So with interior doors, you could order the opposite and install it backwards, and it would be a right-hand reverse or a left-hand reverse. But with exterior doors, it's important to know the difference between a left hand and a left-hand reverse, or the right-hand version of those. Simple Tip Sunday, laying out some batter boards. Mark your pin location above where it is actually on the ground. Make sure you're exactly over that mark. Move your string out of the way and make a little cut. Your string seats in there, it won't move. Math Theory Monday for the problem that I posted in my stories on Friday. Let's go through the solution for this. So a lot of guys said 16, which is at first glance looks right, but it is wrong because this line and this line are not parallel, therefore they can't be equal. So what we're going to do, or what I did, was I solved this right angle triangle here from A to B, C to A, and I got this angle here. Now how I did that is I used my side length here of 8, 4 and 4, that's equal to 8, and this length here, which is equal to 4 because of how the parallel lines are configured here. So there's a few assumptions that need to be made. So to solve for that angle, we use our opposite and our adjacent, which gives us our tan function. Tan equals opposite over adjacent. So that's 4 over 8. So let's do that. 4 divided by 8 is 0.5, and inverse tan function. Tan answer, there we go, 26.565 is our angle right there. Now that can be used to figure out the hypotenuse on this side. We could have gone 3, 4, 5 square and got that side length, but we really only need from there to there. So to get this side length, we can draw an imaginary line right here, parallel to that. Now these lines are equal length. This angle and this angle will be equal. And we have a hypotenuse of 4 right there. So we want to find our adjacent side now, this imaginary line, using our 26.565 degree angle right here and a hypotenuse of 4. So adjacent and hypotenuse is cosine equals adjacent over hypotenuse. To simplify that so we only find our adjacent, we multiply both sides by the hypotenuse, and that gives us hypotenuse times cosine of angle equals our adjacent, the unknown that we want. So let's run that now. Our cosine is cosine 26.565 equals 0.89 times 4 equals 3.5777. So that's this side length right here. Now if we want to find the area, it's side times side, side squared. So we go, our answer squared equals 12.80. That is the area of this square right here. If you have any questions, drop them in the comments, drop them in the DMs. Glad to help you understand this further. Simple Tip Sunday. I've set up this mock out of square corner, which is an outside reality unfortunately, to demonstrate how you can bisect an angle with your speed square. I've used these in the past, but they've got so many scales and so many different reading surfaces that I always get confused. So I just take a straight edge and my speed square, put my pivot on my straight edge, and use the protractor side to reference the other wall. And here we can see we're 2 degrees off 45. That's 47 degrees. So that'll make a perfect miter for this 94-degree wall. Yep. Hope this helps. Simple Tip Sunday. Laying out an ellipse using a square. So for this example, we are 24 by 12. What we do is we set our square in the center of our ellipse and at the edge of our half chords. So 12 inches this way, 6 inches this way. Then we take a scrap and measure out from the edge of that half of our minor chord, 6 inches, half of our major chord, 12 inches, and we set a nail or a screw in each of those locations. Then we hook our half major chord on the end, the tongue of the square, our half minor on the body of the square, and as we rotate that around, we can mark out 1/4 of that ellipse. Flip the square, do the same for each quadrant. You've got a perfect ellipse. Simple Tip Sunday with the chalk line. If you want to tie a tight line that's easily undone, simply make a loop with your finger, give it 1, 2, 3 twists, set it on your nail, pull the slack of the tension side with one hand and eat that up with the other hand. You can keep going with that and make it real nice and tight. All you gotta do to hold it in place, wrap it back around, lock it down like that. That line not going anywhere. Oh yeah, and if you want to undo it, all you do, unwrap it, give it a little tug, and that thing will slide right out. Done. Simple Tip Sunday. Plating efficiently, whether it's by measurement or by in place with your snap lines, will keep production flowing. What I've always done is made one mark on my material and chased my cut around that. It's cut flush, ready to go. Bonus tip if you're still here, set your saw to half the thickness of your material, and at your doors, especially if you're on concrete, undercut where your sill is going to be removed. That way when you go to sawzall or chainsaw out your door sill on the concrete or on your subfloor, you won't hit the concrete, you won't damage your subfloor, you don't have to get all the way through. Tiny Tip Tuesday. I've got a squash block to stick in here, but there's no way to swing my hammer. So I cut a little piece of scrap and use that as an extension. that squash block seated properly. Perfect. Simple Tip Sunday. I've been using the Metabo cordless framing nailer for a year now, and I've really got no complaints except one. That has to do with when you reload nails. You put a fresh rack in, 10 nails later, it'll misfire, it'll dry fire, it won't lock out, but you got to reset the rack before it'll let you continue. So the fix for that is real simple. Unload the nails that you've got in there, grab yourself some tool oil, and with the plunger held back, clean off the ribbon spring at the top of the magazine, put a couple of drops of oil on there, spread that out, and same with the steel track at the back of the magazine. A couple of drops of oil, spread that out. It'll give that slide action nice and clean, and you won't have that dry fire problem while it's trying to change magazine racks. Can keep framing, no hiccups, no cords. Simple Tip Sunday. Not everybody's speed square has that level built in at the top right there. That doesn't mean you can't use it to find plumb or level. What you can do is grab your chalk line or a plumb bob, lock it into your pivot point at the top there, and then when you raise that up until it bisects that 45 degrees, then you know you've found level. Then you can use that as a reference to get plumb, level, cuts, or attachments, whatever you need, but then you at least have a level reference. I had some chatter on a previous post about tape measures and inaccuracy and hooks being loose. This is my daily carry. It's probably gonna fail soon, but you can see the hook's got some play in it. Brand new Fat Max, same tape out of the package. That hook's got the same play. And that's there on purpose. What it does is it counts for the thickness of that steel hook. So when you hook something on, the measurement is taken from the inside of the hook to your number, as opposed to when you butt something in, it's taken from the outside of the hook to your number. So that movement in that hook is what allows the tape measure to stay accurate.